Hello everyone, welcome back to our channel. So in this video we are going to see the prime number check. So this is one of the most frequently asked question in TCS, Infosys and so many companies and in coding interviews and placement rounds also. So let's imagine with a small situation. So imagine that you are sitting in a placement interview and the interview asks you, so write a program to check whether a given number is prime or not. So many students know what a prime number is, but they get confused while writing the logic. So and some forgot the edge cases, some write inefficient code, some cannot explain time complexity also. So today I will explain what is the prime number and how to check it logically and how to optimize it and how to answer confidently in placement also. So let's see. So let's see what is a prime number. So a prime number is a natural number which which is greater than 1 and it has only two factors which is 1 and itself. So that is what a prime number. So it has a only two factors. One is 1 and the one is itself. So for example, here we have a 2, 3, 5, 7, 11 and 13. So for 2 we have only two factors. One is 1 and the one is a 2. So we cannot divide by any other. As for the 3, it also has a 1 and 3. So it can be divided by only 1 and 3. As for 5, also we can divide only for 1 and 5. So for 4, we have a factors for 1, 2 and 4. So we have a 3 digit, right? So we have a 3 factors for the element 4. So but for 2, 3, 5, 7, 11, we have only 2 factors. So it is divisible by only 1 and itself. So that is what a prime number. So let's see what is not a prime number. So for example, so I have said it for 4 we have a factors 1, 2, 3, 1 to 4. So we have a 3 factors. As for the 6 we have a 4 factors. So it will 6 will be divisible by 1, 2, 3 and 6 also. So as like for 8 also. So this is not a prime number. So which a number have a more than a 2 factors, that is not a prime number. Which is less than, so which has a exactly 2 factors, that is a prime number. So always just remember 1 is not a prime number because 1 has a only 1 factor. So this is very common interview trap, which is 1 is a prime number or a not. So 1 is not a prime number because 1 has a only 1 factor which is itself, but a prime factor must have exactly 2 factors. So always remember 1 is not a prime factor. So 1 has a only 1 factor, right? So 1 is not a prime factor. So interview, this is one of the trap. So always remember this. So after this, let's see the logic to check a prime number. So for that we just have to take an input from the user. We have to check the concept. If n is less than equal to 1, that is not a prime number. And we have to check the divisibility from 2 to r n minus 1. If it's divisible, that is not a prime number. If it's not divisible, it is a prime number, right? So if any case the number is divisible by 2, 3, 4, 5, it is not a prime number. If it is only divisible by 1 and the number itself, and that is a prime number. So here we have a 7. So in the logic we have till that r2 to n minus 1 we have to do. So we have start from the 2 r n minus 1. So we take a 7 as our number, means we have to divisible up to 6. So 7 divided by 2. Do we get a 0 as a value? 0 as a remainder? No, right? So this is not a one of the factor. And 7 divided by 3 and 7 divided by 3. So here also we don't get a r remainder as a 0. So this is not a factor. And 7 modulo 4, and that is also not a factor. And for 5, that is also not a factor, and for 6 also. So 7 will be divisible by 1 and as 7. So that is a prime. So and for the 8 will be divisible by 2 and 4 also. And 8 is also divisible by 1 and a 8 also. So it has a 4 factors. So it is a more than 2 factors. Our prime number should have only 2, right? But here we have a 4 factors. So this is also not a prime factor. So let's see the algorithm. So at first we have to take input from the user, and in if condition we just have to check a number. So we have to check a condition. If n is less than equal to 1, it is not a prime number. So we have traded 1 is not a prime number. So if it is less than 1 or equal to 1, that is not a prime number. And uh, and we have to check the condition from R2 to Rn minus 1. We have to loop it, and we have to divide it. If our remainder is 0, we have to declare that is not a prime. If no divisor is found, then it is a prime number. Then stop it. And here is our optimized approach, and check divisibility up to root n only, and factors repeat after square root. So now come to the important part for placement, and here is our optimized approach. So instead of checking from 2 to n minus 1, we just check only up to square root of n. So because why means because factors repeat after square root. For example, if I have a 36 as my number, 36 has a factor 2. It also has a 18, and if it has a 3, it also has a 12. So after square root, factors repeat. So this reduces the time complexity from big of n to big of n root n. So in interviews, if you mention this, it creates a very good impression on you. So here is some applications for a prime number. So it is not just for a academic concept. They are also used in a cryptography, cyber security, data encryption, RSA algorithm. In fact, secure online transaction depend on a prime numbers. So let's code it. So we have created our class inside our main class. So inside main our scanner. So we have to import this. So let's take input from the user. So int n equal to se.nextend, and after that, so in our for loop we have to check, right? So let's take our boolean value. So boolean, I'm just giving a is prime. Okay. So at default, I'm just giving a true. So at first I have to check the test case. So if my number is less than the 1 or equal to 1, it is not a prime, right? So for that I'm just checking in if condition, if n is less than equal to 1, my is prime will be a false. Okay. And else, in a else part, I'm just giving in a for loop, I'm just starting from my index 2. I'm just starting from 2 and up to n minus 1. I'm going to run this, and I plus plus. So here I will divide. Okay. If any case it will go to inside the if condition, it will become a false and we will terminate it. So for dividing, our n modulo I, if it is equal to 0, in any case, my is prime will become a false and we just break it. So after this, in a if condition, I'm just giving a s prime. If it is a true, we just print it is a prime number. Okay. So in a SOPLA, you're just giving it is a prime number. So let's give our n. So in else part, let's give our another value. So if it is any case it is a false, we have to print it is not a prime value. So it is not a prime value. So prime number. So let's run this. So let's give a value as a 5. So we have said it 5 is a prime number in an example. So let's see. So 5 is a prime number. So let's run this again. So let's give our value as a 8. So we have told it 8 is not a prime because 8 has a 4 factors. So 8 is not a prime number. So 8 is not a prime number. So let's try run this. So we just take a value as a 3. Okay, 3 as a value. So at initial, our is prime will be a true. So here we will just check our condition. If 3 is less than equal to 1 or not. So the condition is false. Right? So it will go to the else part and from 2 onwards it will execute. So our I equal to 2. Right? So our 2 greater than what is our n minus 1? Our n minus 1 is 2. So here the condition become false. So it won't execute this part and directly it will tell n as a true. So our prime is a true. So it will come here and it will pass a true value here and it will print it is a prime. So for example, I'm taking a 5. Okay. Now let's take a 4. So if I get a 4, what I will get? So I get a 4. So 4 less than equal to 1. So the condition is false. So here we just have a 2. So here, so now here the condition is true and here it will check. Okay. So n divided by 1. N divided by I. So our n value is 4. So 4 modulo 2. So our 4 modulo 2 is our remainder will be 0. So here we just declare is prime equal to false. So here, so we just change our value true to false. So here it will immediately break it and it will came out of the loop. And now our boolean value is a false. And here it will check if it's a true, it will execute this. But here we have a false, right? So our if statement will not be executed, it will directly go to the else part and else part will be executed. So it is not a prime number. So a prime number has exactly 2 factors and we check divisibility using loops. An optimized approach improves performance and prime numbers are important in security system. And that's all about the prime number check. And before I finish, here are some placement. So before I finish, I'll give some placement tips and always handle the edge cases like zeros and 1 negative. So 1 is not a prime number. So I have already told. So mention the time complexity and explain why you and write a clean and readable code also. And practice similar questions like Armstrong, palindrome, even odd and factorial also. So companies will test your thinking process more than the syntax. So thank you everyone for listening patiently. I hope you clearly understand how to check a prime number logically and efficiently. Keep practicing, keep learning, and all the best for your placement. Thank you. See you in the next video.